Friends, this is Gaurav G Singh, and today I'm back with a new video uh, on the coding interview channel, the Coding Sync. So today we are gonna look at a approach, a design, a pattern. So these days, what I'm doing is I'm trying to learn a bunch of patterns for the coding interview, and I'm trying to learn different patterns so that I can solve coding problems very easily while I'm preparing for the interviews. So this is one of the pattern I saw. So the name of the pattern is the two pointer pattern. Two pointer pattern. So I have added some description about this pattern. So suppose in problems where we deal with sorted arrays or lists, and need to find a set of elements that fulfill certain constraints, the two-pointer approach becomes quite useful. The set of elements could be a pair or a triplet or even a subarray. So suppose think about that you are given an array of sorted numbers and a target sum. Find a pair in the array whose sum is equal to the given target. So if you have to solve this problem, what we will do is we'll consider each element one by one, and then iterate through the remaining one pointed by the another pointer to find a pair with the given sum. And it looks that the time complexity is of n square if we go with this approach. But the thing is, in this case, the input array is sorted. So an efficient way would be to start with one pointer in the beginning and the another pointer at the end. And every step will see if the numbers pointed by the two pointers adds up to a target. If they don't, then we'll do one of the two things. So if the sum of the two numbers pointed by the two pointers is greater than the target sum, this means that we need a pair with a smaller sum. So we'll try to find more pairs. We can decrement the counter, the endpoint counter. But if the sum pointed by the two is smaller than the target sum, that means we have to go to the right. So then we need a pair with the largest sum. So we can increment the start counter. So I will explain it to you one by one. So let's suppose, so this is we are writing this thing in JavaScript. So let's try to write out like two. Let's assume there are two parameters, two pointers. So pointer one, which is pointed to which points to the first element, and the pointer one, which points to the first element, the pointer two, which points to the last element in the array, in the sorted array. Okay, and then I will just loop through this array one by one. I less than 4, let I equal to 0, I less than array dot length I plus plus. So what I'm doing is I'm just looping through this array, and then I will just try to find out the array, that the element at the pointer 1 plus element at the pointer 2 is greater than the target sum. So this is one case, and the other case is if it is less than, or I will put this equal to here. So if this is greater than, if the sum is greater than target, then what we will do, we will decrement the pointer 2. Think about this, like in this case, suppose 1 plus 6 is 1 plus 6 is greater than 6, so that means we have to go to this element right here, so it will be 1 plus 4. And in the other case, we will just increment the first pointer to pointer 1 plus plus, and then and at the end what will happen is, and we have to find out when it's equal. So I think this algorithm might be wrong, because this is just saying either less than or greater than. So I think we'll have a greater than here, and we will add one extra condition here with else if less than, and then else what we'll do, we'll just return the array, right? Does that make sense? So in this case, what I have to do is we have to return, so let's look at the problem, to return the indices of the two numbers. That means we have to just return the indices. So that means we have to return ptr1, comma ptr2. And that's it, I guess. And then we can break from it. I think it's better to break here and then return the numbers there. So let's try it out what happens in this case. So this is returning 1 and 3. So I think this is returning 1 and 3 here. So I think this is good enough for us because this is returning in the for loop. I'm just thinking, like, do we have to put this conditional in the for loop, or we can put it outside? I think let's take this out because I don't like it here. Maybe I will just break from it now. I think this is fine. Yeah. So this is giving us the answer. So 1 means this one, and 3 means 2, 3, 4, 2 plus 4, 6. And then after that, this will be, yeah, I think this is fine. Otherwise, if it will loop through it and it will return negative 1. If it returns negative 1, that means it doesn't find anything. So if I will look into the time complexity of this problem, I think the time complexity is of n. Since we are just looping through the array just once, so the time complexity would be of 1, and space complexity, I think it's we are not as such using anything, so it will be of 1, sorry. And so when I was looking into this problem, I see a problem which has to be avoided. So think about that if these numbers are big enough, suppose this number is which is like out of the bounds for an integer, then what will happen? If we are gonna run this will fail. There will be an integer overflow error. So instead, so let's try it out. What happens? Oh, I think it works because it didn't complain. But I think it's better to avoid this thing by, instead of doing like the pointer array at pointer 1 plus array pointer 2, we should do target minus pointer 1 greater than this. So that way we will just subtract it, and then the integer will never overflow. So let's talk about this solution. So I will just copy this, and okay, I think I'll just move this statement here. So I think this way there will not be any problem. There will be no overflow, and we got the same results. So I think this is the go through this thing to briefly overview what we discussed today is the two-pointer approach. In the two-pointer approach, it is helpful. First of all, it is helpful in case of a sorted array. And what we do is we loop through the array one by one pointer to the start and the other pointer to the end. And then we keep on, in this case, we keep on calculating the difference by target minus pointer 2. So if it is the target minus pointer 2 is less than the pointer 1, then we'll do pointer 2 minus minus, otherwise pointer 1 plus plus. And this way we will get the indices for this pair with the target sum, and that's it. So Thank you for watching my video tonight and have a nice day, and we'll see you in the next video. Thank you.